In this video, we are looking at section 6.2, talking about one-to-one functions. Now, if you recall functions have a specific definition. It is a mathematical relationship in which each x value has one unique y value, as in no x value has more than one output, or there's not more than one y value associated with a given x value. And one way we look at this was the vertical line test. If you draw any number of vertical lines through particular x values, it'll only intersect your graph once. An example that fails the vertical line test was this horizontal parabola. The horizontal parabola, which is still a mathematical relationship and equation. Ooh, that took a sharp turn there, but we're going to pretend that went straight off there. But it fails the vertical line test because, oops, let's change that up. Because a vertical line will hit that graph in more than one place, in this case, two places. So to be a function, you can only have one y value associated with a given x value. This x value right here has a y value there and another y value there. So this is not a function, and this right here is a function. Another way we looked at it was with mappings. With mappings, we said that each x value can only have one given y value, one given output. So 3 maps to -6, 4 maps to 2. We could still have two x values mapping to the same output. That's okay. We just can't have this. We can't have an x value that goes from let's say 3 to -6, and also, come on now, 3 to say 18, because that x value has two different outputs, and that we cannot have. To be a function, each x value can only go to one y value. We are now going to look at a subset of functions called one-to-one functions. And one-to-one functions, what's nice about them is that they are extra neat and clean. It meets all the definitions of a function. It passes the vertical line test, the mapping checks out, but it's a subset, it's a particular set. And in one-to-one functions, the textbook writes it like this. They say f of x1 cannot equal f of x2. Now, this is a general sense, which means any two x values, whatever they are, x1, x2, part of the domain of this function, the output of f of x1, the output associated with x1 cannot be equal to the output associated with x2, as in each x value has its own unique y value. So this example we did right here, this would not qualify because the input of 4 and the input of 6 both give us the same output value. And what one-to-one functions are saying is that you cannot get the same output regardless of what your input is. So for a mapping, it might look something like this. If that's my inputs and it's going to map onto this right here, each input must have its own unique output. Now, for that reason, this parabola, which is a function, would not qualify as a one-to-one because the same y values are getting used twice. So this is 2, 4. That's the 2, 4. Input of 2 gives me an output of 4, but the input of -2 also gives me an output of 4, which means 4 is not a unique output for that function. For a one-to-one function, every input must have its own unique output. One input, one output. One-to-one function. So graphically, let's have a quick look at graphically what this might look like. So graphically, oops, a little shaky there. Graphically, a good example is a basic cubic function. As in f of x equals x cubed, a cubic function. So 0 cubed is 0, 1 cubed is 1, and then 2 cubed is 1, 2, 3, 4, 5, 6, 7, 8 right there. So it takes off. And then negative 1 cubed is negative 1. And negative 2 cubed is negative 8. I'm ballparking, it's about right there. But what you'll notice is each x value corresponds to exactly one y value and only one y value. No y value is used for any other x values. 1, the point 1, 1, this point right here, 1, 1, is the only point on there that uses an output, a y value of 1. 8, the y value of 8, there's only one x value that gives us that, it's 2. Every output is unique, it's only used one time. Now, when we look up here to see if something is a function, we had this nice thing called the vertical line test. And it was to make sure, we used the vertical line test to make sure that no y value was used, each x value only had one y value. Well, down here, we have what's called the horizontal line test. Ooh, that's misspelled horizontal. Let's try that again. Horizontal line test. The horizontal line test allows us to visually see if a function is a one-to-one function. So what I mean by that is this. If I draw horizontal lines, is any y value used more than once? Does it touch more than once on a horizontal line? Now, if we go back up here, clearly this fails a horizontal line test. While it is a function, it is not a one-to-one function because the y values are used more than once. The cubic function, though, is a one-to-one function. It passes the horizontal line test. So to be a one-to-one function, a function must simultaneously pass a vertical line test and a horizontal line test to demonstrate that it meets all the qualifications of a one-to-one function.